Continuing with more questions for functions, types of functions. Now I've taken a question here, and here the question says a function f from R to R, that is the domain as well as codomain, is a real number, and the definition of the function, the fx is defined as fx is equal to x cube. We need to check whether this function is 1, that is its injectivity, or onto, that is its surjectivity. So like every question, we will also make an arrow diagram first to understand. Let's say I made this the domain and the codomain. Clearly, we have a domain as R here, that is all real number. So is the codomain. Now, if I take some, say, integers and negative integers, or if I take, say, 0.5 a decimal as it's a integer, then I can take 1, 2. Now I'll take, say, -1. I'm deliberately taking some values, say 0.25. Oh, it's a cube. So 0.125. This is 1 and 8. I can check some other values also. Now, as I can see that the function definition of the function is x cube. That means if I place an input as -1, if I place an input as -1, the cube of -1 is -1, cube of -2 is -8, cube of 0.5 is 0.125, cube of 1 is 1, cube of 2 is 8. So what do you see here, that the image of distinct element, that is -1 and -2, they are distinct, right? No two y here. There is no two element in the codomain, right? Is the image of two different elements in the domain, right? We can see that this is 1 to 1, right? So this is clearly a 1, 1 function. Now let's check whether it's an onto or not. Now, what you can see here, that since the domain are all real number, right? So every number that is there in the codomain must be the image of some element in the domain. So it will be an onto function. But let's see how we are going to prove it. We will take, as in the previous questions, we take fx is equal to x cube is the question. So I'll take fx is equal to y, and replacing fx with y from this question, we can say y is equal to x cube. Now what you will get x as, writing x in terms of y. Now check here the input, right, the y, as you can see that y is a real number, right? Y belongs to R, and this implies that y raised to the power 1 by 3. That means if y is a real number, the cube root of any real number is y. Yeah, the square root may not be, is not, but cube root of every real number. So y belongs to R implies that y raised to the power 1 by 3 also belongs to R. Right. Since y is a real number, y raised to the power 1 over 3, that is cube root of y, is also belongs to R. So x, y raised to the power 3 is nothing but x. So x belongs to R. So what we'll say that hence for every y that belongs to R, there is an x that belongs to R such that fx is equal to y. And therefore, we'll say it is an onto as well as 1, 1. And as you must have been explained in my previous videos, that a function which is both 1, 1 as well as onto is called bijective. So this we can further add that this is a bijective. This is bijective, as it is both 1, 1 as well as onto.